This will be for the con exercise. Determine if a function is invertible. All right, so the definition of a function, it is an equation for which any input x that can be plugged in has only one output, which would be y. The function is invertible if you can swap or exchange the x and y and still fulfill the above definition. Okay, so we're going to do that in this exercise. If you can exchange the x and the y and still have only one output for each input, then the function will be invertible. So it says f is a finite function whose domain is the letters a to e. Okay, the domain is just the x values, and it says the following table lists the output for each input in f's domain. So f of x right here, this is the y values. So the domain is the x values and the range is the y values. All right, so they want us to do the mapping diagram first. So you just click and drag on this diagram here. All right, the side on the left is the domain, the x values. The side on the right is the range or the y values. So A is associated with 1. Okay, so you take the line for A, you click on it, left click on it, hold it down, and drag it to the number 1. All right, for B, it's associated with 2. So you take the line for B, left click, hold it down, and drag it to the number 2. Okay, C is 3. So for C, drag it to 3. D is 1, and E is 2. Okay, for D, you click on it and drag it to 1. And then for E, click on it and drag it to 2. Okay, so that is our mapping. And now they ask if the function is invertible or not invertible. Let's see. So in the original setup, the left side was the domain or the x values, and the right side was the range or the y values. So we want to see if you can switch or reverse the x and the y values first. Okay, so now this side becomes the range or the y values, and then this side is the domain or the x values. And we want to see now if now that we reverse that, if it's a function. So each input or x has to have only one output or y value. So if this side is now x, you plug in 1, you might get A or you might get D, okay? But it has to have only one output. So this one, once you reverse it, it's definitely not a function. So that means it's not invertible, okay? You can't reverse the x and the y and still have it fulfill this definition. So the answer is no, or not invertible. All right, one more. I think these are all the same. Okay, the inputs are the x values, the outputs are f of x or the y values. So A is associated with 61. So you go to A, left click on it, hold it down, drag it to 61. For B, we have negative 31. So go to B, click on it, drag it to negative 31. C is 71. D is 101. Left click, hold it down, and drag it to 101. E is negative 11. All right, so we did our mapping. And then say if it's invertible or not. Okay, so this was the original domain or x. This was the original range or y. We want to reverse them first. Okay, and then we want to make sure for every x that we plug in, we only get one y for the output. All right, so if you plug in 31, you get B. -11 you get E, 61 you get A, 71 you get C, 101 you get D. Okay, there's nothing on this side that has two different branches. Okay, there's only one output for each input. So in this case, it's yes, the function is definitely invertible.